In this video, we'll go through why variable rate seeding and how Advantage Acre can be used to create variable rate seeding recommendations. In order to create variable rate seeding recommendations, three pieces of equipment are needed. You need a GPS system that has 6-inch pass-to-pass accuracy or better. You'll need an in-cab controller to control the planter drives, and a planner with variable rate drives. These drives can either be hydraulic drive units that control sections of the planter, or electric drive units where you'll have an individual electric unit on each planter row unit. Why variable rate seeding? Most fields are going to vary in productivity 50 to 150 bushels an acre in corn. In our example field shown here, Zone 1 has a yield potential of 230 bushels an acre, compared to Zone 4, which has a yield potential of 170 bushels per acre. Fixed rate seeding is a trade-off in that you overplant on the lower yielding areas and you underplant in the high yielding areas. This sacrifices yield on these higher yielding areas or more productive areas of the field and increases seed costs on those lower yielding areas. The foundation of creating variable rate seeding recommendations is based on Justice von Liebig's Law of the Minimum. The Law of the Minimum states that growth is dictated not by total resources available, but by the scarcest resource, or what is the most limiting factor. For variable rate seeding to work, in higher yielding areas of the field, plant population is the barrel stave that most limits growth and yield, where in the lower yielding areas of the field, some other factor is the most limiting, and farmers then are spending too much money on seed. This is an example 40-acre field with 4 equal-sized management zones, for the sake of simplicity. If this field is planted at a fixed rate of 32,000 seeds per acre, population is the limiting factor in zones 1 and 2, and thus yields are reduced from their potential. Where in zones 3 and 4, some other factor than plant population is the limiting factor, and seed costs could be reduced and not limit yield. We will now variable rate plant this field. The hybrid curve we are using is a simple straight line curve where at 150 bushels an acre yield potential, 24,000 seeds an acre will be planted. And at 250 bushels an acre yield potential, we would plant 40,000 seeds per acre. In our example field, in Zone 1, we increase our population by 5,000 seeds an acre. By increasing the population, we decrease the likelihood that population is the limiting factor, and yield increases from 230 bushels an acre to 240 bushels an acre. Notice that the size of each ear of corn decreases from 40 longs to 36 longs. In Zone 2, population increases 2,000 seeds an acre, and yield increases by 5 bushels an acre. In the case of Zone 2, population can't be raised as high as in Zone 1 because some other factor becomes limiting more quickly. For Zone 3 and 4, population is not the most limiting factor, and population can be reduced and maintain the same yields. The benefit is the seed savings cost and not increased productivity. For our example field, we can calculate the return on investment, or the ROI, for switching to variable rate planting from the fixed rate planting. In order to do this, we have to make a couple of assumptions. The assumptions are that the price of corn grain is $3.50 a bushel, and a bag of seed corn costs $250. The basic formula to calculate ROI is price for corn grain times yield minus the cost per bag of seed times the population. So for Zone 1, we would take 350 times 240 minus the $250 for your bag of seed divided by 80,000, which is the number of seeds in a bag of corn, times the number of seeds we're planting. So you get a gross income minus seed of $724.38. The field average ROI was $12.38 an acre for this variable rate seeding application. In Zone 1, this ROI is $19.38 an acre. This comes from an increase in yield, but will also have an increase in seed cost. Zone 2 has an ROI of $11.25 an acre with a smaller increase in yield than Zone 1 and a smaller increase in the cost for seed. For Zone 3 and 4, yield doesn't increase, but seed cost decreases to give an ROI for variable rate seeding of $4.69 and $15.63 an acre for Zones 3 and 4 respectively. Now that you know what equipment is needed for variable rate seeding and have a better understanding on how and why variable rate seeding works and the potential ROI, we'll now cover what is needed to create a variable rate seeding recommendation. The first thing that is needed is to define how much variation there is in the field and to create a management zone. Next is determine how the weather in the upcoming growing season will impact the management zone. We also have to estimate the yield potential for the upcoming season, which ties kind of directly into what the upcoming weather is going to be. We then have to actually find out how is this hybrid going to respond in different yield potentials. So planting one hybrid, how is it going to be different from another? There are many different methods or strategies to create management zones. We'll review some of the most common methods. One of the most common and simplest methods is to create management zones is to use the USDA soil survey and assign a population to each soil type in the field. While USDA Soil Survey Data is a great resource, it lacks the resolution needed to create variable rate seeding zones. I'm going to group aerial imagery and yield data into the same category as a post-mortem diagnostic tool. Both of you will tell you what happened the previous year, but don't provide much insight to what other limiting factors and the why of the management zones and how to help increase yield overall. Organic matter sensors are becoming more and more common and are a great tool to help make management zones. While organic matter is a major factor in the productivity of a field, it is only part of the equation and must be complemented with other soil layers and management practices. Similarly to organic matter sensors, the standard soil fertility test is a great tool, but only part of the equation. It must be complemented with other soil layers and management practices. Most soil tests only look at pH, pK, and some other nutrients occasionally in the upper 2 to 10 inches of the soil. There's a lot more to determining soil zones than the current nutrient status. Soil electrical conductivity correlates the electrical resistance of the soil to some other factor. The primary correlations are to soil texture and organic matter. While this is a good tool, it can be fairly expensive and still only gives part of the picture. In Advantage Acre, we have chosen to use a management zone creation method called functional soil mapping. Functional soil mapping uses elevation data paired with soil data to make highly accurate soil maps that can be used to create management zones. The functional soil mapping technology is a patented technology that was developed by soil scientists at Purdue University. The field mapping technology works on the premise that the primary variability in soil on a field level is caused by changes in soil elevation and how water has then shaped and changed the soil over time. To create these maps, we take the digital elevation model, i.e. elevation data for each field, and use the data to calculate other values from that data set. Example here is topographic wetness index, slope, modified catchment area, and these things called geomorphons. From this dataset, we calculate the optimal sampling locations in the field, and finally, sample the field for soil attributes that have the greatest influence on crop productivity. The sampling is first done using data from the USDA Soil Survey, and then can be updated later on with data collected directly from the field. After calculating the functional soil map, multiple layers are combined together to create what we call the productivity index. The index combines multiple layers that are critical for crop production and weighs each layer to create management zones for each field. The productivity index managed zones are modified then using weather trends and long-term weather forecasts. The modification takes into account rainfall, soil texture, and where each management zone is located in the field relative to ponding and runoff. This indice is called the topographic wetness index. Productivity index is just a scale of 0 to 10 showing differentiation between different areas of the field. To create a variable rate recommendation, we need to add a yield goal to the field. This yield goal is entered in the seed plan of Advantage Acre. From the yield goal, management zones are created around the variability in the field from the productivity index. The final step is to match a hybrid response to population. When a user selects a hybrid, each AgriLion hybrid has its own unique curve that will relate population response to yield. Curves for each hybrid were developed from intensive population trials conducted by AgriLion. The example curve shows 5 different hybrids and the response to population. If you select a hybrid with a response to population like the orange line, in most cases variable rate seeding will not be needed. Contrast that to a hybrid like the gray line where the population changes dramatically between 100 to 200 bushels an acre, but then starts leveling off as you approach 250 bushels an acre yield potential. So now that we've gone through and we've reviewed the equipment needed, we've gone through to talk about how do you create these. Really now let's go through the steps to create variable rate seeding recommendations in Advantage Acre. Step 1, you need to go into Advantage Acre and you need to create a field. creating fields is a fairly simple process that can be as easy as selecting the common land unit for the field you want or uploading a field boundary that you already have in shapefile format. The next step is to go in and click on the Soil tab in the Functional Soil Map and validate that the productivity index is relatively similar to what you would expect your management zones to look like. The next step is to go in and create a seed plan. You can go in and you select the hybrids you want to place in the field, along with entering what you think the yield potential for this field is for this upcoming year. The next part, once you complete the seed plan, is to change to variable rate from a fixed rate seed plan. After you switch to variable rate, you have the ability to modify the variable rate recommendation in multiple different ways. In some cases, the productivity index using functional soil map does not take into account factors such as landform changes that you've made, if there's been previous other management practices where the field was farmed differently over time, then you can then adapt to using your own local knowledge. The next part is you have to save for purchase, so you save it for purchase, you make the purchase, and check out. After you've checked out and made the purchase, you can either export the variable rate recommendation as a shapefile and download it to your local computer, or you can send it to Climate Field View or My John Deere. You can do this not only from your purchases window, but also from the field itself. The final step, and in the example shown here is the Precision Planting 2020 monitor, is to go and load that variable rate recommendation onto your planting monitor. So thank you for listening to this video, and as you go through, if there's any other additional questions you have about variable rate seeding, feel free to reach out to the team at Advantage Acre.